And today, depending on who shows up and how many folks have questions, I wanted to focus mainly on the bigger picture in terms of what might be going on this summer, not just in California, though of course I'll talk about California as well, but across the rest of North America and even globally, because this is, or at least has the potential to be, a fairly remarkable summer in terms of global heat and what all this means in the broader picture of what we've seen in recent years, because we've already experienced the past 12 months of exceptional record-breaking global heat and the long-term context of course, the dramatic increase in temperatures in the long term. So what does this year mean in the context of all of that? What are the outlooks telling us about what might be in store in California and in the western U.S. and more broadly? And also, what does all this mean for fire season? Again, within California and beyond, because I think the beyond part of that is maybe a more interesting part of that conversation. And so there's a few graphics that I wanted to share. These are all essentially seasonal predictions. And I won't talk too much today about the caveats and the uncertainties associated with seasonal prediction, because I have emphasized those during dedicated sessions at other times, but I'll just re-emphasize them briefly, which is to say that seasonal predictions always represent tilts in the odds. They're different than deterministic weather forecasts, which predict specific conditions at a particular place at a particular time, whereas seasonal outlooks are making probabilistic estimates of what overall conditions over broader regions might look like over multiple months. And the reason why that's an important distinction is it's a different kind of prediction problem, structurally and scientifically, and in practical terms, it means that we do not have as good of seasonal predictions as we have short-term weather forecasts, because the short-term weather forecasts are largely conditioned on the initial state of the atmosphere right now. And we understand the physics well enough to predict how that state of the atmosphere right now will evolve over the next few days, usually. We have fewer signals to work with, at seasonal scale, and that means we also don't understand the underlying relationships quite as well as we do. So we can kind of squint a little bit and make vague predictions, some of which are better than others. And there's also the notion of predictions of opportunity, where we know that some initial conditions for seasonal prediction perspective are more likely to result in a prediction that is correct than other conditions. So often when we say that seasonal forecasts are pretty bad overall, it's because we're lumping together years where there's very high predictability, theoretically, along with years for which there's very low predictability, even theoretically. So we kind of get uninspiring statistical skill scores if we mix these all together. But if we only focus on those locations and times where we expect that what we know about the world should be predictive of what's going to happen, then we actually do end up seeing that there is meaningful something. We can say something meaningful sometimes in some places, and probably not at other times and in other places. So this year, there are reasons to believe that there actually is something meaningful we can say about predictability, and so that's what I'm going to talk about today. Welcome, folks. I know there's a lot of folks trickling in, but just wanted to also emphasize that I am really trying to, as social media becomes complicated to navigate these days, really trying to grow the YouTube channel. So I really do encourage folks to share these, both while I'm hosting these actual live office hours in the moment, and also after the fact. These are recorded, and I think a lot of folks would find them worthwhile even to view in retrospect, especially sessions like this one. So feel free to share the link, the same link that works for the live link in real time will also work for the archived recorded version. Sometimes there's a little bit of a lag. YouTube needs to process the video, but it's usually up within a couple of hours at worst. So I'll start with California and zoom out. California has had a pretty favorable winter and spring so far from the perspective of, I guess you could say, hazard mitigation for the most part. We saw what was along the coast a wetter than average winter virtually everywhere, especially in Southern California, but not so wet a winter that there was widespread severe flooding. There was some significant flooding locally, although this had more to do with isolated torrential thunderstorm downpours than it did large-scale storm systems, thinking about the flash floods in places like San Diego and Long Beach and Ventura, and even parts of the city of San Francisco. But the major river systems, for the most part, did not see severe flooding, so we got a pretty wet year in most spots without having as significant as flooding as we had last year. This year was, of course, not as wet as the previous year, but it does mark the second above average winter season in terms of precipitation on average in California, and that hasn't happened in a long time previously. The modest exception is that the Sierra Nevada was not as wet as coastal California, and many places there were near or even slightly below average for seasonal precipitation. There might even be a pocket near South Lake Tahoe and Reno that was even moderately below average for the season. But that is really the exception rather than the norm. And even in the Sierra, the snowpack at present is pretty darn close to average in an era where we haven't seen very many average years in terms of snowpack. So that number is somewhat remarkable in its unremarkableness, because we have this skewed distribution. We've had a lot of years recently with a very high snowpack, last year being one of the highest years on record, and also a lot of years with just catastrophically low or nearly absent snowpack, with also in the last decade having 2 different years at least where most places saw their lowest snowpack on record. So it's been a topsy-turvy snow decade in California, and this year, as of April, the snowpack is pretty darn close to at least the recent average, which is good news, combined with wet conditions along the coast, meaning that there are unlikely to be significant water scarcity impacts this year in California. Does it completely resolve the groundwater crisis in the San Joaquin Valley? No. But does it mean that our surface water supplies and our reservoirs are in good shape for this year? It does. Does it mean there will be meaningful runoff into reservoirs into the late spring and early summer months? It does. So that is relatively favorable news from a water supply perspective. Now, there are reasons why that doesn't necessarily tell the whole story about what ecosystems experience. And this becomes important for talking about wildfire conditions. The reality for this year is that I think, honestly, we're going to see a slow start to wildfire season, both in California and in some other parts of the West that have seen a good snow year and wet conditions overall over the past year or two. So I actually think that the risk of really problematic or dangerous wildfires will be quite low across most or all of California for the next couple of months at least, probably into June and maybe into July in some places even. So even when the season might normally be kicking into higher gear, it might still be pretty slow into July. That does not mean there will be no fires. There have even been some minor ignitions this past week, but you may notice that these are not fast-spreading, dangerous, high-intensity fires, and that is largely because the conditions are pretty damp. The vegetation is very green. There's not a lot of residual dead, dry stuff yet, because there may be some dead stuff, but it's not dry. It's still pretty wet. And that's likely to continue in the absence of any major heat waves, the continued occasional spring showers for the rest of this month and probably through May, as well as some of the seasonal conditions, which I'll talk about in a moment. But right now I'm focusing on the antecedent conditions, what we know is true as of right now. So not relying on seasonal predictions yet for this part of the conversation, but just reflecting on what has transpired as of today. to the extent that we are certain as to what happened recently. So California has been wet and cool recently. There's going to be a lot of additional vegetation growth. We saw a lot last year as well. Last winter especially being a very wet period with a cool, damp spring. That is very favorable for vegetation growth. This is good for ecosystems that had a rough time during the historically severe droughts, including back-to-back droughts. In the 2010s, that decade was a rough one in California, ecologically speaking, and in terms of drought and wildfire. The last couple years have been much kinder to these same ecosystems that really struggled. But the context is not that we've somehow reverted back to some long-term normal, but instead that we're just seeing a swing of the pendulum in the other direction for now. It will eventually swing back. And that's important context for thinking about what might be coming next. But right now, what we see is a period where the natural vegetation in ecosystems across California have seen a lot of growth. And this is true across, really transcending California's very diverse biogeographies, all the way from the redwood forests along the coast to the southeastern deserts. The Mojave Desert has been pretty wet, and there have been various folks discussing about what qualifies as a super bloom in the desert, with some desert ecologists rolling their eyes at the term. But the reality is there's been a lot of growth of both perennial and annual plants, even in otherwise very dry parts of California over the past couple of years. We've heard about the rise of Lake Manly in Death Valley, and how for the first time in a long time it's been possible to paddle a kayak across a pretty significant swath of the valley floor in Death Valley. Of course, that is reflective of there being a lot more water in the basin than has been the case in most recent decades, most recent years. So you might imagine there'd be a lot of growth of plants, and you'd see the shrubs flowering nicely, and of course that's exactly what we've seen. And it's not just Death Valley, but broader swaths of the California deserts too have seen similar blooms and vegetation growth. And deserts are, of course, ecosystems that are adapted to boom and bust cycles. That is usually the nature of a desert. It doesn't rain for a long time, and then it rains a lot all at once. And most desert plants and animals are adapted to that kind of boom and bust climatology, although even there is a certain range of variability that species are adapted to. And recently we've seen excursions, certainly outside of the 20th century, variability both on the dry and wet sides in the California deserts. So that is notable. Right now it's a wet cycle in the deserts, certainly, and we're seeing that reflected in vegetation growth. One challenge there is, especially in regions of the California deserts and the Great Basin, which has also been quite wet over the past couple of years, for the most part, is the preponderance of invasive grasses that have been introduced over the past 50 to 100 years and have really taken over some of these landscapes. This is true in some settings more than others, of course, but overall there is a problem in the Great Basin and in parts of the Mojave with invasive grasses. And the reason why this is a real problem, well, there are several, and then it crowds out native vegetation, but also from a fire perspective. One of the reasons why many desert regions don't see very large wildfires most of the time is because vegetation, of course, is sparser than in moister regimes. And also, the vegetation that does grow is often discontinuous. So you can imagine in a lot of Great Basin, if you've ever driven on I-80, for example, across northern Nevada, you see that there are often clusters or clumps of shrubs and then gaps largely in between them, at least where the grasses haven't filled in, or in a dry year. So you can imagine if there's a lightning strike during the summer monsoon or something that strikes a particular sage bush or something and ignites it, that might burn that bush and a few adjacent plants, and then that fire kind of sputters out because there is, in the absence of either really strong wind conditions or unusually high vegetation growth in between these clusters, not a lot of contiguous fuel to connect the dots, if you will. But if you have the arrival of these invasive grasses, which, if you will, fill in the gaps in between these contiguous vegetation clusters in some of these desert settings, then if you have a wet year and a lot of growth of grass in that year, you now have what's known as a continuous, or a more continuous at least, fuel bed. So you still have those clusters of native vegetation, sagebrush, whatever else is growing there, but now you have these invasive grasses, which are themselves fairly flammable, but more importantly fill in the gaps between these clusters of more discontinuous native vegetation. And that can lead to fires that are much larger and sometimes reach a higher intensity than they would otherwise. We've seen this with pretty dramatic effects in some parts of the Great Basin and the southeastern California deserts in recent years, thinking about events like the Dome Fire, for example, multiple fires that have occurred in and near Joshua Tree National Park, which have killed a lot of Joshua trees because these are not species that are particularly well adapted to fire. Sometimes there would be fires among the Joshua trees, but often they'd be pretty isolated. Lightning might actually strike a Joshua tree and it might burn along with a few adjacent ones, but again, because of that historically discontinuous vegetation, those fires would be limited in scope. But in recent years, we've seen very large, multi-tens of thousands of acre type large wildfires that burn at pretty high intensity and, more importantly, burn a large fraction of these ecosystems all at once, because partly due to the invasive grasses, but also in these wet periods where the invasives really fill in the gaps. And that has been a historical challenge, and it's something I would expect to potentially see again this year. So when I say I think that the fire season in California will be off to a slow and late start this year, that is true everywhere except for possibly the desert regions. Places that don't often see significant fire seasons at all might actually see one again this year, and it might emerge earlier because, of course, it gets hot and dry in the deserts earlier than it does anywhere else. And so if there is continuous vegetation or excessive growth of annual and perennial grasses and shrubs, as there probably will be in a year like this year, we're already seeing that in some places, it does mean that places that don't often see big fires might see them this year and might see them earlier than other places. So it would not be surprising to me to hear about some early season fires, pre-monsoon fires, if you will. So between now and July, in the deserts of southeastern California and perhaps into the Great Basin as well, so into Nevada. But mostly though, it is good news from a California early fire season perspective. We're not going to see fires in the upper reaches of the Sierra Nevada until at the absolute earliest July, at least meaningful fires. And it's probably going to take a while even in the coastal regimes too. There's the coastal mountains, the Bay Area will probably be late start to the season and a slow start to the season too. However, and I will talk about this more when I talk about the seasonal prediction, I do not think that we can extrapolate that to understanding how the fire season will end. In fact, I think this year is a year where there's a pretty good chance we'll have a slow start, but a particularly pronounced and perhaps intense finish, and one that perhaps lasts longer than usual. So I say this because in recent years there have been a lot of announcements about how fire season is so mild in July, and how this is a portent of how fire seasons have reverted to some norm. That was never true, but in a year like this, I feel like it might be particularly misleading because I think that we may genuinely have an unusually slow start to the fire season and an unusually intense finish in parts of California. I'll talk about why in a moment, but part of the why, again, just looking backward, antecedent conditions, we've had some really wet conditions both this year and last year in coastal regions, and especially in the mountains last year, with a relatively decent winter even in the mountains this year. That means that vegetation has grown a lot. And also because we've had two very quiet fire seasons recently, it hasn't burned much. So despite all of the intensive fire activity in the 2010s, millions and millions of acres in California, now, the last couple of years, we've not seen very much fire activity at all in California. So we've seen a lot of vegetation growth and not a lot of fire activity. What this means is that there is now a much higher unburned biomass than there was a few years ago during the drought. And it also means that some of the more recent burn areas, even some of these burn areas that were in the hundreds of thousands of acres, have really started to fill in with new vegetation. And for a long time, it was believed that essentially that you had a pretty prolonged reprieve in the post-fire regime in much of the West, where you'd have a wildfire, it would clear out a lot of the vegetation if it was of sufficient intensity, and it would take decades for it to build back to the point where you could have higher intensity fires once again. I think we're starting to learn that that's really not necessarily the case, where in some settings you really only get a couple of years of a break. Of course, you can't regrow a mature forest in 2 or 3 years, but what you can regrow are, well, you guessed it, annuals and some perennials that survive fire. So you get a lot of shrub and grass type growth. Many of the burn areas in California from the past decade, especially the ones that are more than 3 or 4 years old. So at this point, the historic fire year of 2020 is now essentially 4 years ago. So this is most of the major fires. And then, of course, the late 2010s are now getting hard to believe, closer to 10 years for some of those fire burn areas. These footprints are now filling in with a significant amount of vegetation, and the conditions the past couple of years have been particularly conducive to the growth of grass and brush. So the brush in some of these places is now above head height, and in some settings we're seeing regrowth of trees. So of course, there's no mature forests that have regrown, but in places where there is growth of new trees, those trees are probably getting close to waist height or higher. So what you've got in some of these prior burn areas is what is quite frankly a fairly explosive, potentially explosive mix of head-high brush and waist-high trees, along with grass filling them in. So this is, by the way, one of the reasons why it's really important to follow up with prescribed fire treatments in regions that have recently burned, because there's actually now, in the past couple of years, a really strong and growing level of evidence that burning once isn't enough. In fact, sometimes you can increase the likelihood of a fast-spreading wind-driven fire in the 5 to 10 years following one of those kinds of fires, because you now have a uniform crop of new tree starts that are just a few feet tall and brush that might be 6 to 10 feet tall, and that is the kind of vegetation that probably is most ready to burn. If you have relatively sparse ground level head height vegetation but a bunch of mature trees, that's actually a lot less flammable. So you have these trees that are 50 to hundreds of years old. Often those are a lot more resilient to burning in many fires. In fact, with a lot of lower intensity ground fires, those trees aren't going to burn at all. It's going to be difficult for the flames to get up into the canopy. But now, in a lot of these burn areas, especially the high intensity ones, we have fewer of these mature trees left, or they're still there, but now there's this uniform crop of vegetation between about 1 foot and 10 feet tall. And that is a recipe where if you have dry conditions and windy conditions, you can actually get a pretty high intensity fire now moving through those locations. So in places where there have been prescribed fire treatments, this risk is greatly reduced. And again, this is including even areas that burned in a wildfire 5 or 10 years ago and were followed up by a prescribed fire treatment more recently in the past year or two. These are the places where there probably isn't going to be much of this problem over the next few years. But of course, we still aren't doing prescribed fire at the scale that we would need to, even to treat most of the recently burned areas in wildfires in California, let alone the rest of the landscape. So there are going to be some pockets of good news there, but overall, I think a lot of these burn areas are now filling in with pretty dense brush and new tree starts in some locations. And so I guess the moral of that story is, I don't think that the fact that large swaths of California's open lands burned over the past 10 to 15 years is going to be that protective anymore moving forward. It might change the nature of the fire from being more of a forest fire to being now more of a grass or brush fire in some of these places, but under sufficiently dry and windy conditions, that can pose just as much of a threat to communities. So my point here is that this transition from a decade with some historically severe drought to some very wet conditions now sets the stage whenever things do dry out moving forward. for a very active wildfire period again, because there was probably some attenuation after 2020. Things got wetter, of course. We didn't see as much record heat, but also we had just burned the heck out of a lot of these lands, and at some point you burn enough area that you do start to decrease the amount of fuel or the fuel contiguity between these regions, at least temporarily. And what I'm emphasizing now is after 3 or 4 years at a minimum, and in some cases closer to 5 to 10 years now, those gaps are starting to fill in once again. And it's also likely that our relatively cool and wet period the last couple of years, at least compared to the past decade or so, is likely going to be coming to an end, possibly as soon as later this year. And so that's one of the reasons why I think, not even considering future predictions right now, but just looking backward to antecedent conditions, why I think this season may be one of those transition seasons where we start off quite mild in terms of fire season, except possibly in the deserts, for the reasons I mentioned earlier, but have a very strong finish. So that's California. Across the rest of the West, again, in terms of antecedent fire conditions, there's pretty strong evidence that we might see an early and severe start to the season in places like New Mexico and parts of Arizona. This is, of course, a part of the West that has an earlier fire season peak than the rest of the West. It's in the pre-monsoon period, so before July. May and June are often peak fire season. Not always, but often in Arizona and New Mexico, because once the summer monsoon arrives, it can help moisten the landscape. But often May and June can be some of the hottest, driest months of the year. And this year, there is expected to be a particularly hot and dry May to June period in the context, especially in New Mexico, of severe drought conditions already. So there could be an early and aggravated start to the season. But that looks very different as you go north into the Rockies, where in Colorado and Utah, for example, very good snowpack right now, probably a later start to the fire season. But once again, I think in the Rockies, the slow and late start to the season might mislead about how the season could end, because I think here again is another place where we've seen a lot of moisture recently. We will have seen a lot of vegetation growth recently, and there's an elevated likelihood of a very unusually hot summer to come, and that may dry things out come autumn. Talk about that in a moment. So I think in the Pacific Northwest and into Canada, maybe I'll focus on Canada. We're already seeing an unusually early start to fire season in parts of interior British Columbia and Alberta in early April. In fact, there are currently evacuations in British Columbia already for wildfires. They're not widespread yet, but this is early. Some of these fires actually might even be holdover fires from last year. They never were completely extinguished. They were in remote areas burning in very dense vegetation during a historically severe drought. And essentially, it never really got wet enough this winter to fully extinguish some of them, because the severe drought continues up there. Much of the interior of British Columbia and Alberta are likely to have a very severe fire season again this year unless something changes dramatically. I think we're already starting to see that. So Western Canada will likely see an early start to fire season, a particularly severe fire season overall, and potentially a long-lasting fire season. So there will be a lot of fire emissions from Canada, both in the terms of greenhouse gases and also particulate matter, so smoke. This will probably affect the Pacific Northwest at times, the Northern Rockies at times, and like it did last year, perhaps even the central part of the country and the east coast of the United States with that long-range smoke pollution. California is a little less susceptible to seeing smoke from Canada because, as you might imagine, it would have to take a pretty unusual path due north to south or even northeast to southwest to make it to California. So it doesn't happen too often, every once in a while. But California is probably the least likely place in North America to see smoke effects from Canada this year. So some good news there. But, as I mentioned, California's second half of fire season might be more intense locally. So Canada is going to be off to a roaring early start. Looks like it already is. That might be true in New Mexico as well. California, though, and the Rockies probably off to a slower than usual start, and perhaps a milder first half of the season too. This is when I think it makes sense for me to pull up some graphics and show them on the screen. So I'm going to share my screen, and you may recognize some of these images from my most recent blog post, which I suggest that folks check out if you want some more details on what I'm talking about today. And obviously right now it's probably looking pretty small on the screen. I'm not asking anybody to focus at anything individually yet, so I'm going to blow up a couple of these maps, make them larger. By the way, this is from the Copernicus database. This is the essentially the European Climate Change Service, but which also offers a nice consolidation of seasonal prediction from the existing short-term operational multi-month sort of climate prediction ensemble models. And what's nice about this is it's the plots are pretty good, and the plots are good, and the representation is broad. And now that I've blown up this sample plot, you can see that this is produced by Copernicus, but it includes data from all of the major modeling centers on Earth. So the European, the ECMWF, the Met Office, which is the UK model, Media France, obviously that's the French center. DWD is the German center. NCEP, by the way, that's the American model. So the CFS is in here, but it's only one of multiple JMAs, Japan, etc., etc. So these are most or all of the major world modeling centers. And what I want to show first, so this is a prediction generated in April, so this month. Actually, it'll be updated in a couple of weeks for May, but this is a prediction generated using the April conditions at the beginning of the month for May, so for next month. And I'm going to step through multiple months here for multiple variables so we can infer some more broad things about how things might change. But just making sure that this is showing up. Yeah, that shows up nicely on the screen. I think it's big enough for everybody to see, and to see the labels and the unit values, which is ever important, because if you can't see the units in science, you're lost. So anyway, this is essentially a prediction from these multiple international predictive models for the relative temperature anomaly for May, so for just the coming month. And of course, it's important to think about what the base period is, because the climate is changing. It's especially with temperature, because it's warmer virtually everywhere. This is relative to a baseline from the early 1990s to about 2009. So actually, this is relative to a baseline that's already significantly warmer than the 20th century. So these maps are actually less red, in other words, than they would be if we used a 20th century baseline. So these are predicted departures from average for a particular calendar month relative to the warmer baseline recently. And so it's saying something, is really what I'm getting at, when you see a lot of red on this map, because this is suggesting places that will be warmer even than the last 20 years or so in the coming months. So essentially, this is what May looks like. This is the global map. There's a lot of red, a lot of orange and a lot of red, but there's a few places where there's not. One of them is the tropical Pacific, and this is essentially due to the early emergence of a La Nina-like signal next month. So in the global models, La Nina is projected to really start to take shape, and the tropical Pacific will complete its transition from strong El Nino to developing La Nina as soon as next month, with some cooler than average temperatures showing up in the eastern equatorial Pacific Ocean. If we zoom in, and I'm going to do this for North America, again, this is a nice tool because it's easy to do this. What we see once it loads is that from a North American context, Baja California, as well as California Norte, are going to be likely the least anomalously warm places in almost this entire domain. There's a couple of other little blue blobs, but essentially California, or most of California, ends up in this plus minus zero point 0.2 C region. So really not greatly above or below the recent average. This is, again, to note, still warmer than the 20th century average. So if we had a 20th century baseline, everything on this map would be yellow and red. But because we're using a baseline, or they're using a baseline, that incorporates some of that warming that's already occurred through 2009, California may not be much warmer than that recent baseline. And that may be partly an early developing El Nino to La Nina transition signal, where we tend to have late season low pressure systems that continue to dive south over California in these kind of transition seasons. We don't tend to see particularly warm near coastal sea surface temperatures either in these transition periods, and I think that's what the models are probably picking up on, which is to say May probably won't be a particularly warm month across California, but it looks pretty damn hot across a lot of the rest of North America. Particularly, I mean, look at Canada. Yikes. Western Canada, man, this is not a good signal given that there's already ongoing severe drought and wildfires developing in April. And then Central America looks extremely warm as well. So this is, again, for May, and I'm going to step forward in time, of course, to June, which actually looks pretty similar to May. We see an expansion of this super hot air mass across the interior portion of the desert Southwest. So this is sort of New Mexico in June. That's one reason why I think the New Mexico fire season in May and June might really get going. Well, look at California and Baja California. Once again, the only really location in this entire model map with near to even slightly below the recent average temperatures. So June might not be a particularly warm month in California either. The exception might be, again, interior California, so the southeastern deserts might start to get hot. And by hot, I mean hotter than usual. It's already usually pretty hot in June. So this would suggest that the heat might start building across inland areas, but for most of California's population, generally the coastal region from the Bay Area south to the Mexican border, looks like even June might be pretty mild by recent standards. Pretty good case for June gloom and cool coastal marine layer temperatures. Once again, Canada's on fire, literally and figuratively. Yikes. Things start to get a little bit different in July. We still see this white area along the Pacific coast, the Pacific Southwest coast, but it's narrowing, and more of California is in the yellow or orange. And we also see this enormous blob of potentially extreme heat expand to encompass almost all of central continental North America. So essentially all of Canada east of the Rockies, and all of the U.S. essentially east of the Rockies, going down into Mexico. This is an exceptional signal for very warm temperatures. Again, this is 1 to 2 centigrade, so on average, at monthly scale, potentially 3 to 4 or more degrees Fahrenheit above average across this entire region. That's a big number across such a large area. But the other thing I want to note is that this is at the peak of the monsoon season across the Southwest. So this is July. This is some pretty extreme heat, especially the eastern half of the monsoon zone. But watch what happens when I get into August. Okay, so now this signal, and again, this is not one model, but this is all of the global model ensembles blended together. For August, this signal gets even more extreme and even more widespread, and increasingly now edges into California. So now most of California does actually look like it will be warmer than average by the time we get to August. This is going to be particularly pronounced across the interior and the southeastern deserts, but we do now start to see some spillover of this mid-continental gigantor ridge and heat wave expanding westward towards the coast, and now this does start to include California. Again, there's still a narrow zone of near average temperatures offshore, but we can see that this extreme heat over continental regions is starting to spill westward, more so even than it usually would as we get later into summer. Again, central and western Canada just baking, but also this is why I think the Rockies, even places like Colorado and the Northern Rockies that have seen relatively decent moisture levels this year and last year, after a few months of this potentially extreme summer heat, it's really going to dry out. And there, now you have this effect spreading westward as the summer progresses of places that have seen a lot of moisture recently and a lot of extra vegetation growth, which is good for ecosystems in the short term, are going to dry out to the point where they become very susceptible to fire. And now they're going to have much higher fuel loading, vegetation density. So we sort of have that combination of very wet recent conditions, extra growth, and then once we dry it out with a potentially extreme summer of heat across inland areas, now as we head towards autumn, and I'm going to move into September here, we see, this is going to show up momentarily. Oh, it already did, so I almost didn't, there we go. So the difference is that the extreme heat recedes a little bit across Canada, but it expands even closer to the California coast, and it stays entrenched across from the central Rockies westward to the California coast. This is the season where I think August through potentially November, and this seasonal ensemble doesn't go out through November yet. It will as of a few days from now when the model updates for the May 1st cycle. But my point is, for the models that do go out into November and December, they suggest that a continued progression of this extreme heat even closer to the coast over this period, with a fairly high potential for next autumn to have a late start to the rainy season in California. So I mention this for a couple of reasons. One is that it's going to be a back-weighted summer in terms of heat, perhaps even more so than usual. So we often tend to see heat waves develop first across inland areas in the inland deserts, and it takes at least until August and maybe until September or even October for that extreme heat to make it to the coast in California. That's sort of the classic autumn heat wave in San Francisco kind of pattern. This year, I expect that to be even more pronounced than usual, and it could be quite extreme in autumn. These are large signals at seasonal scales. I know 3 or 4 degrees Fahrenheit doesn't sound like a lot, but when you sustain that kind of anomaly for months on end over continental scale regions, it likely involves individual, rather extreme heat waves that are either very intense and or very persistent. So a lot of these regions that are orange and red, and again, almost everything is orange and a lot of areas were red at some point, that's a very strong heat signal. And I think it's going to extend increasingly close to the California coast as we get into autumn. So across the southeastern and inland desert areas, maybe the Central Valley by July or August, and the coast probably by late August or September, and perhaps lingering into October and November. Now I want to look at, I'm going to have to go back. I want to look at precipitation. I'm going to look at the same sort of situation here. I'm going to zoom in once again on North America. Again, precipitation seasonal scale predictions are not as good as temperature, so we have pretty good skill for the temperature predictions, which is why I'm emphasizing them first. We have significantly less skill for precipitation. However, again, this year we have a decent signal of a strong El Nino event decaying into potentially a significant La Nina event. So this is one period where there might in fact be a little bit more predictability regarding seasonal scale precipitation than there would otherwise be. Especially for the summer. So this is again a prediction for May. And honestly, most of these signals are pretty weak in terms of precipitation. I wouldn't read too much into this across North America, except perhaps the dry signal on the central coast, west coast of Mexico, and perhaps around Hawaii. Those are likely pretty reliable. But as we go into June, this is the pre-monsoon period or the early monsoon period in northern Mexico. This is a very, very strong dry signal. So the early monsoon period, the monsoon normally emerges first across the northern interior of Mexico in June and progresses northward into July and August. This suggests that the early monsoon period is likely to be quite weak, since again, this is suggesting that the multi-model ensemble average is this is a tercile summary. This is suggesting that there's 60 to 70% agreement across the ensemble that the early monsoon will be in the lowest third of all historical years in this region across Mexico. So that's a pretty strong signal. Again, this is a little bit different. This is not saying that the values will be 100% below average. it's saying there's 70 to 100% confidence in the models that it will be substantially below average, for example, which is a bit different than the temperature maps that I was showing, which was actually showing the predicted temperature anomaly. As we go closer to the peak monsoon now, this is July. This is once again not quite as strong, but still a pretty strong signal for a weak monsoon across the whole monsoon region. This corresponds to a low precipitation, high temperature outcome for the summer across the core monsoon region. That's not great news. I wouldn't read anything into this little signal off of the west coast of North America. It's just too weak to be meaningful in summer. But the other signal that's meaningful, the dry signal in Hawaii, so the drought risk there will continue. And look at this big blue and green blob. Nearly 100% likelihood in parts of the Caribbean of well above average precipitation in July. You know what that's telling us? It's a bit of an uh-oh if you live along the Gulf Coast or in the Caribbean, Central America, because it's telling us of a very high likelihood of a very active tropical cyclone season in this part of the world. We go into August. Still a relatively dry signal. It's a little more dispersed across the west. This is the late monsoon, so again, suggesting there's likely to be a poor monsoon across, more likely than not to be a poor monsoon this year. Again, emphasizing that we don't have great predictions of monsoon seasonal precipitation. So I hesitate to say take that with a grain of salt, because this year I actually think that there's one of those years where we probably have a little more predictability than usual, but also it's not the be-all and end-all. It's never more than a tilt in the odds. Maybe we'll get lucky, but right now, this is what the odd tilt is telling us. Again, noting in August, this region of extremely high confidence in a very wet period expands across the Caribbean and Central America. This could be a real doozy of an Atlantic hurricane season. And of course, those storms start earlier in the season in the Caribbean, and then later in the season you get more Cape Verde type storms which originate over in the Eastern Atlantic. We go into September. That active signal in the Caribbean, you actually see that Cape Verde signal start to emerge. Now, as we get into September, there's a broader dry signal across much of the interior west that's starting to expand across California. Now, of course, September is not historically a wet month across California, but in the models that do have data going out to October and November, they're suggesting pretty high statistical confidence in a dry fall and a late start to the rainy season in California. Now, if you combine that with what's likely to become a rather hot or even very hot late summer and early fall period, that potentially sets the stage, especially from the central and southern Rockies westward to California, for a pretty significant second half of fire season, perhaps one that is dramatically more active than the first half. So I'm really hoping we don't see stories this year in July saying just how mild the fire season was in California. Because I do not think that conditions in June and July are going to tell us anything in California or the Rockies about what's going to happen from August through October. And if some of the models are correct, potentially even into November in some places, if there truly is a very late start to the rainy season. Again, something that is speculative at this point, but there is likely to be an elevated probability of that this year as we transition towards significant La Nina conditions. So that's about all I got to say about precipitation, but there is one more thing I wanted to show. And we're used to, some of us at least, are used to looking at geopotential height anomaly maps. But I wanted to zoom in once again on North America here, and I'm going to go back to the actual magnitude. So this is not a measure of statistical confidence, but this is an actual map of the projected geopotential height anomalies. One of the things you'll notice is that, in this case, the entire map is at least yellow and much of it is orange and red. This is because in a warming world, the 500 millibar layer is rising everywhere. It's rising faster in some places than others, but it is in fact rising everywhere to the point where now it's permanently above average all the time, even relative to a recent baseline. So that's saying a lot. But what's interesting here is you can still tell spatial patterns from the relative anomalousness. So look, over California, the geopotential heights will be least above average. Try that one on for size. But because they are least above average, what it means is that California will actually be effectively in the relative low geopotential height zone relative to adjacent regions. So this is one of the reasons why California is likely to be cooler than many other places on the continent in May and June, is that there may be increased trophiness in early summer. So this might be increased likelihood of April and May showers from transient low pressure systems. That's being reflected at scale with the 500 millibar geopotential height projection. So as we go forward into summer, into June, I think we're going to see that pattern starts to reverse itself. So California is no longer as much of a local minimum. But as we get into July, we start to see that this subtropical ridging southwest of California gets really strong. And this is why, as we get into later in summer, we see this pattern of really high geopotential heights over the northeastern Pacific, extending now to a big ridge by September. This is why I'm thinking that this is the kind of pattern that would result in a dry, hot autumn, and that is a pretty strong signal here at this point. And the last thing I wanted to show, zooming out, is the 850 millibar temperature. So this is the temperatures in the atmosphere significantly above the surface. So around a couple thousand feet, depending on the pressure profile above the surface. This is sometimes a smoother field because it's a little bit above many of the mountain ranges, not all of them, but many of them on Earth. And it gives you a better sense of what's happening in a way that is less dependent on microclimates and geography. So this is the prediction for May. Again, almost everywhere above average. A few spots that aren't over the remote southern hemisphere, and also, again, over southern California, where the lower atmospheric temperatures aren't as much above average. But watch what happens as we head later into summer. This is now going to show up for June. All of a sudden, all the white spots fill in across the whole northern hemisphere. As we go through summer, we see that, again, that the center of central North America, Mediterranean, southern Europe, as well as the interior of most of the continents, frankly, South America, interior southern Africa, northern Africa, parts of Australia, the Indian subcontinent. Boy, oh boy, do things just get warm. And by the time we get to August, now, most of the northern hemisphere is really red. And so this is suggesting that the lower atmospheric temperatures almost everywhere by the end of northern hemisphere summer are going to be extremely hot. This is potentially indicative of another summer of record heat in the northern hemisphere. We start to see patches of relatively cooler air. I mean, look at this. It's barely below average. Certainly doesn't counterbalance the red and orange everywhere else across the southern hemisphere. But again, these are mostly in remote southern ocean regions where no one lives. But over almost all the populated parts on Earth, including, importantly, the populated parts of the southern hemisphere continents, so southern Africa and South America and Australia, super hot. Of course, there it's going to be winter in August, so unusually warm winter signal. And now, up in the northern hemisphere, across almost all of continental North America, and by the time we get to August, extending even into California and across a wider swath of Europe, very warm, anomalously warm, lower atmospheric temperatures, and that just further expands into September. In fact, look at what happens across the southwest in California in September. Big red blob, the ensemble mean. This suggests that it's quite likely that the air mass August into October in California at lower levels, this is a pattern that you'd expect to see associated with major autumn heat waves across the southwest. So I think this is going to greatly influence the wildfire season, given this combination of unusual vegetation growth leading up to it, this period, and then the potential for late season extreme heat across much of Western North America. And also, look, just this whole map is orange and red. All right, so I'm going to stop sharing my screen now. I haven't looked to see whether folks have commented in a while, so I'm going to take a step back and do that. Take a sip of water, etc., etc. All right. The last thing I wanted to say before I start looking at the questions and answering them, and feel free to add them as I'm talking, is that there is a real question as to whether the Earth it's not going to cool off in any meaningful sense, because unfortunately the main reason we're as hot as we are right now is global warming. But there's still natural variability. There's still stair-stepping, on our way up to warmer temperatures due to natural variability along that staircase. One of the profound drivers of that stair-stepping and that natural variability is ENSO, El Nino and La Nina. Usually during El Nino, we end up getting a boost of a couple of tenths of a degree centigrade in global average temperature, which is probably part of the reason why the spike last year in temperatures was so big, but it isn't the only thing going on. Of course, the main reason why we're up at this high level is global warming, and then there's several things going on that have a step even higher than that last year going into this year. El Nino was one of these, but now that El Nino is on the way out, there is an expectation that global temperatures will level off and probably, hopefully, cool relative to last year by 2025. So this is often a lagged response. Global average temperatures don't suddenly just plummet the second that El Nino goes away. We would need to see a sustained La Nina event for a while for global temperatures to really plateau or decrease slightly relative to last year. There is some question about whether that's actually going to happen, because if you look at global sea surface temperature anomalies as of this week, they are now higher even than they were last year. So again, La Nina has not yet begun. We do not yet have a La Nina influence exerting any sort of temporary cooling effect, but we should probably by the end of this year and certainly into early next year. So my prediction is that we will stop seeing continuous record warmth globally by early 2025. That's not as impressive as it sounds. It just means that we won't quite be at the record-breaking levels set last year, but may well still be above almost all previous historic values, but for last year's record warmth. So it does not mean that there's the start of some long-term cooling trend. It just means that the natural variability may be temporarily back in a direction that is de-emphasizing the warming rather than accentuating the global warming trend. However, this summer, La Nina probably won't arrive soon enough for that to happen. And also, in the mid-latitudes of the Northern Hemisphere, summers with La Nina conditions developing are often hotter than summers with El Nino conditions developing. This is because of changes to the atmospheric flow patterns. So the tropics relatively start to get a little bit cooler, and we saw that in the global temperature maps for this summer, but the mid-latitudes can get temporarily warmer. So this summer, that's one reason why there's a pretty high likelihood of record-breaking heat across the Northern Hemisphere continents, because of this residual extreme warmth from the past year or so from global warming, plus the transition to La Nina may result in an even higher spike in some continental regions this summer. So yikes. It's already been a pretty extreme sequence of years, and that might actually get even more pronounced this summer. But I do think that 2025 will probably be a little bit cooler. Now, this is an important point. That's a prediction. There's not a guarantee that that's going to happen. And there is a little bit of, I guess, a difference of opinion among climate scientists about exactly how weird or unexpected the 2023-2024 heat spike has been. I tend to agree with the perspectives that this was not really outside of the realm of what could have happened under a continuation of the expected trend. Because we know that there is natural variability on top of that long-term warming trend, and there were some natural cycles last year that probably should have pumped up global temperatures by an even greater degree. Does it fully explain the recent and frankly ongoing warming spike? That's where the contention is that it doesn't necessarily. And I think depending on how you quantify it, really affects how you interpret this. There are some definitions by which, for example, if you ask whether 2023-2024 is outside the range of climate model predictions for individual temperature spikes at this point in history, in the 2020 to 2025 period, the answer is no. This is within what climate models suggested should be happening right now. 2023-2024 are particularly at the higher end of some of those years, but they are within the range of where these models suggested that natural variability could get us to on our warming trend as of right now. But, it is at the upper end, and the real test will be what happens next year. Because if we really are just experiencing primarily a spike in this natural variability that just is bad luck on top of the long-term warming trend, which is always possible, but we've gotten unlucky, then that should begin to at least temporarily level out next year. If it doesn't, then that's going to raise a larger set of more troubling questions that are more troubling already than the very troubling ones that we already have to address with the warming that we know is happening, about why this spike happened and, more importantly, why it's maintained. If this spike essentially levels out and temporarily cools a little bit next year or the year after, I don't think we really need to invoke any exotic explanation for what happened. But if it doesn't, then that actually does become an important question to address. Do I think that we've actually hit a sustained level at or above 1.5 C of global warming as of right now? I don't think that we have, because I think that over the next couple of years, it's fairly likely the temperatures will dip back down below 1.5 degrees temporarily. They will essentially inevitably rise back above it and on a more sustained basis in the years to come, perhaps sooner rather than later. But I don't think we're there yet in terms of multi-year exceedance of consecutive 1.5. But I'm not 100% certain about that, and there is some unease in the climate community surrounding what, if 2024 is also record warm and it doesn't cool off much in 2025 globally, then what? What do we infer from that? So that's speculation and just some again unvarnished thoughts from the mind of Daniel Swain on what's going on and what I'm thinking about and what the community is thinking about at large. And I think there are some important questions still to be answered in this context. But this summer looks like a hot one across continental North America, certainly. And again, that's not glib. When I say, oh, it's going to be hot in summer, that means hotter than it would usually be in summer. Of course, it's trivially easy to predict that July is going to be warmer than January in the Northern Hemisphere because, of course, it's summer, and that's just a function of the seasons, which are still quite reliable. But when I say it's going to be high odds of a really hot summer in many regions, that really does mean hotter, not only hotter than the recent average, but potentially record hot in some places, and that is a concern, given that it comes on the heel of pre-existing record heat. Okay, that's the global big picture. There aren't too many questions, so I think I can get through all of them. Let me take one more sip of water, and I'll go through this quickly. Good morning to folks who have expressed their greetings. One comment about how Washington State in the northern headwaters of the Columbia are just around 60% of average for snow water equivalent. So yes, the Pacific Northwest could see a fairly active fire season this year, although there it is always more conditional on weather. So you don't just need heat waves there, but you also need heat plus wind events. That could happen this autumn. We'll see what happens. But the places where I'm most confident in these predictions are up in Canada, where it just looks bad by any dimension. New Mexico, where it looks pretty bad by any dimension. And then I think that this transition from an unusually mild to an unusually severe fire season looks possible all the way across this swath of central portion of Western North America, from about Colorado westward into California, starting in July, maybe in Colorado, and progressing westward into California as we get towards August and September, and perhaps beyond. Yeah, Timothy mentions that the Northern Rockies are in pretty bad shape. Yes, so I think that the Northern Rockies may see a fairly early start to fire season, much like Western Canada. So the interior BC, Western Alberta, probably in a somewhat similar shape to Northern Rockies. The drought there isn't quite as long as it has been in Canada, but I think that we may see more activity in the Northern Rockies earlier this year as well. So I would include that, and that may increase the level of smoke impacts across places east relative to the prevailing wind patterns. Yeah, Stu mentions another interesting potential reason for some of the grass invasion in the desert. Well, I hadn't heard this one. The deposition of nitrogen, essentially from air pollution in urbanized Southern California, so sort of smog as fertilizer. I am not an atmospheric chemist nor an ecologist, so basic things sometimes come as news to me. But that is interesting. I'm guessing there's a somewhat limited sphere of influence. That might explain things more in like the lower Mojave places like Joshua Tree Preserve. It probably, I would imagine, it's somewhat less relevant across like the interior Great Basin, where in some cases the invasive grass problem is even worse. So it certainly doesn't help things locally, but there are a bunch of reasons why this is occurring. But from a fire perspective, it doesn't matter as much why there is more invasive herbaceous vegetation in the deserts. It just matters that it's there, and that also that it's very responsive to wet periods, because of course, grass grows quickly and it can respond to a single wet year or even a single wet month, depending on the species. All right, and then finally, a couple of questions from Jack Lee. I believe this is Jack of the San Francisco Chronicle. The first one is the potential heat this Northern Hemisphere in the summer and fall related to why it was so warm in 2023? Well, I mean, I think I answered this largely. Again, the main reason why it's as warm as it is global warming / climate change, whatever you want to call it. If you have to walk up 10 flights of stairs, if the temperatures this coming summer, let's just use this, are essentially a 10-story building, or the anomalousness, say, of the temperatures this summer are a 10-story building, anomalousness relative to maybe, 100 years ago or something. Well, you can get to the 8th floor with global warming, so that's the main answer. But then, there are these other factors going on too that get us the other 2 stories to the top. Maybe one of those stories is last year was El Nino in terms of global warmth. This summer could be the transition to La Nina in terms of these more localized patches of Northern Hemisphere continental summer warmth. And then there's that last story, that last 10% or so. Not totally sure what that is. That could be a combination of things like changes in ocean currents and changes in aerosol pollution, including the much discussed aerosol pollution from ships, and a bunch of other things. So it's there, but we're already on the 8th floor from global warming. And ENSO is there kind of doing different things and giving us another story, and then there's maybe one more floor coming from everything else. That's kind of how I would think about it, and roughly in terms of order of magnitude. We may have to revisit that a little bit if 2025 doesn't cool down. But for now, that's sort of how I'm thinking about it, order of magnitude wise. So yes, there is a lot of overlap, although we will be transitioning from El Nino to La Nina, so the ENSO-related part of it will be different than last year and will favor different regions. So last year, record warmth in the tropics and subtropics is favored by El Nino. This summer, it might be more record warmth in the Northern Hemisphere extratropics, the mid-latitudes. So, in other words, closer to where we all live in North America. Perhaps not everybody on this session is in North America, but I suspect that's a strong majority of the people who watch these sessions. And then Jack's other question is, have warmer global temperatures affected California weather in 2024? Stronger storms, more rain than snow? Well, we're living in a warmer climate that affects all weather. Every single weather event that unfolds, whether it's a, unremarkable mild day, as I'm looking out the window right now, or an extreme heat wave or an extreme rain event, all of those unfold in the context of a warmed climate. So all of them are affected by global warming. But that's probably not the answer Jack was looking for. So the more specific answer is, my null hypothesis, until proven otherwise, is that extreme precipitation events, particularly intense short-term downpours, of which there were a lot in California this year. We've talked about this recently in terms of intense thunderstorm downpours and the flash flooding we saw in places like San Diego and Long Beach and Ventura and even San Francisco. A good null hypothesis is that those events are about 10% more intense than they would have been without global warming so far. Plus or minus, I put a range on it, maybe 5 to 15%. So again, centered on about 10% more intense. That might not sound like a lot, but it can make a pretty big difference in terms of outcomes. Some events are going to be more than others, but that's sort of what I would expect. So until somebody can give me good evidence to the contrary, just from basic atmospheric thermodynamics and the increase in the 7% per degree centigrade or so, or 3 or 4% per Fahrenheit increase in the water vapor holding capacity of the atmosphere, I'd expect that the extreme precipitation events are about 10% more intense in California and in other regions. You notice this is a similar answer to what I gave for the extreme event in Dubai last week, although there's actually some evidence that that one may be even more than 10% because it's kind of a hot spot of global precipitation increase that might be more than 7% per degree centigrade. But for California, let's call it about 7% per degree centigrade. Again, last year we were globally about 1.5 C above the long-term average, so take that 1.5 times 7%, and that's approximately the percent by which you are greater than your historical average in terms of precipitation extremes, not in terms of overall precipitation. We do not think that we do not actually know whether California's overall average precipitation may decrease or increase in a warming climate, but we are pretty darn sure that the precipitation extremes will increase roughly at that rate. Also, as you mentioned, we saw a winter where at least the first half of the season was characterized by really high snow lines and where snowpack accumulation at lower elevations was really abysmal until later in January. So there's probably a climate signal embedded in that anomalous warmth and high snow levels, although we ended up having colder storms with better recovery toward the end of the season. So we were kind of saved by the bell there with cooler, certainly not frigid, but cooler temperatures, and more importantly, relatively cool temperatures, or just cool enough temperatures that coincided with significant precipitation to give a big snowpack. So the first 2/3 of the snow accumulation season are very much illustrative of what it looks like when you have a warmer atmosphere, but you still get some precipitation, you get higher snow lines and less accumulation, although things did get better later in the season. But I think from this past winter, for me, the signature of climate change is probably most present in these short-term thunderstorm or thunderstorm-like convective rain downpours where some places saw 1, 2, 3+ inches of rain in an hour in places that rarely or have never experienced rainfall intensities of that magnitude. And this resulted in significant flash flooding in places like San Diego and Long Beach and Ventura, etc. this year. So for me, that was the flavor of the most obvious link to climate change this year with these winter events, with the caveat again that every event is influenced in some way by climate change, even if it's not always exactly traceable what that influence is. Some events are less intense because of climate change as well. That's the nature of things. But on average, when it comes to precipitation extremes, heat extremes, on average, they are more extreme today than they would have been. So stay tuned. We may be doing some more specific research on these hourly type precipitation events in a warming climate in California. Not enough hours in the day, months in the year, years in the decade, etc., but just an early preview. Oh, and then the final question from Doyle Rice, USA Today. Could this be the warmest summer on record in the U.S.? It's possible. It's more likely to occur this year than it is in most years. And again, the main reason for that is that, we got to the 8th floor with global warming, but now this transition to La Nina can bring an extra warming boost over North American continental interior as La Nina develops. And so, yes, it's possible. The Climate Prediction Center is predicting very high odds of much warmer than average summer across almost all of continental North America. So if you combine the high statistical likelihood of a warmer than average summer across essentially all of continental U.S., if you combine the geographic breadth of that very warm signal that I showed in the maps earlier across all the ensembles, especially for July and August. With the intensity of that signal, in many parts of the continent, it's as much as 2 centigrade, or nearly 4 degrees Fahrenheit on multi-month average. That's a very strong signal across a very broad region, strong both in magnitude and statistical likelihood. So, I'm not in the business of making official seasonal predictions, but I would not be surprised if summer 2024 was among the warmest on record, if not the warmest on record in the U.S., the continental U.S. That wouldn't be tremendously surprising to me. All right, I think that about covers it. I need to move on to the next thing. I'm afraid to look at my email inbox, taking an hour away from it. Anyway, thanks for joining. Please continue to share the channel because I am really going to make a concerted effort to grow it this year. Good questions today. And I will talk to you all next time. Next week's session, TBD. Stay tuned, and if you want to be notified, of course, the best way to do that is to sign up for the YouTube notifications, but I also now regularly post announcements across the full breadth of social media. Of course, I'm still on Twitter /X, whatever you want to call it, but I've continued to scale up on other platforms. I'm on Blue Sky, post there open to the public. I'm on Threads, which now posts to the Fediverse, meaning that if you're only on Mastodon, you can now see me on Mastodon via the Fediverse. So it's become a complicated social media landscape out there, but I am everywhere. So, but I still think that these YouTube sessions are uniquely helpful in terms of the platform and the formatting. I just want to scale up the audience because you're getting, as much as it's nice to have a one-on-one conversation with folks, it would be great to have an even larger audience. I still find that during these episodic extreme weather events, there can be hundreds or even thousands of live viewers, but during most of the regularly scheduled weekly sessions, we usually cap out around 100 or so, which is still a good audience. And sometimes it's nice, honestly, to be able to answer questions from most of the people who submit them. So it would be nice to have a mix of sessions where some of them are small groups of people and other ones are very large audiences. So we'll see if we can ramp that up at a manageable scale. Anyway, thanks everybody. Have a good weekend. Talk to you later.